Okay guys, you all know I love the dollar tree where everything used to be a dollar until recently it was now $1.25, and I love that it is $1.25 for two reasons. Number one, it helps to spark classroom conversations about fractions because that 25 cents is a fraction of a dollar. It helps to spark classroom conversations about decimals because $1.25 can be written as 1.25. All those help students to understand how classroom mathematics can be used in real life, okay? So, I love the dollar tree. I'm going to use that example of the dollar tree in this problem to show how two quantities are related in a proportional relationship and to calculate the constant of proportionality as the unit price in dollar tree, okay? And then write an equation of proportionality plus graph the proportional equation. Okay, so let's get started. So this table represents items bought at dollar tree. Okay, so you can see here number of items and the price in dollars. So one item $1.25 because we're not worried about tax, no nothing. So two items will be $2.50. Okay, and 10 items will be $12.50. Now the question is, are the number of items and their prices proportional? Okay, so in order for us to find out if they are proportional, we need to know what a proportional relationship is. A proportional relationship, one item is a multiple of the other. So let's find out if there is a multiplier here or a constant of proportionality. So in this scenario of the dollar tree, the unit price, okay, the unit price or the price for one item is the constant of proportionality. So we have been told here that one item costs $1.25. That makes $1.25 a multiplier. It does not change. The cost for one item is not changing. It is a constant. It is a constant multiplier. So let's find out if that is the multiplier that is working throughout. If we multiply $1.25 by 2, we get $2.50. Okay? So if we multiply $1.25 by 10, we get $12.50. If we multiply $1.25 by 100, we get $125. So $1.25 is the constant of proportionality. Now for any table of a proportional relationship, if we want to determine if that table is proportional, then that constant of proportionality must be the same for all values. The constant of proportionality is always denoted by the letter K. So we say K for this table is $1.25 per one item. So that means if we use any pair for two items, if we want to calculate K using two items, that should be $2.50 divided by 2. That gives us the same value of $1.25. So this table is proportional because every time when we divide the price by the number of items, we get that constant number. Do we get the same number if we divided $12.50 by 10? Yes, we move that decimal place one place to the left, and we have K $1.25. And the same thing here, 125 divided by 100 is 125 hundredths, which will be $1.25. So there is a constant of proportionality, and here we see that the constant of proportionality is the same as the price for one item. So if you're looking on the table, if you're looking for the constant of proportionality on the table, go to the price for one item or the output that matches with 1, that will be the constant of proportionality. Now, can we write an equation that can be used to model this proportional relationship? Yes. Okay? So all proportional relationships have an equation that looks like this. Y equals K times X. All right. This Y represents the Y-axis, and the Y-axis takes the output values. The x-axis takes the input values. Now, it is now for us to determine which one is the output and which one is the input on our table. The number of items is the input because that is what you take in order to determine the price. So this is going to be your x values. The price now depends on how many items you take. So that will be the dependent or the output, and this will be your y values. So based on this table, to write the proportional equation for this table, we need the variable y to represent the prices. So y here will represent the prices. And then we need to know what this k is. Remember, k is the constant of proportionality that we found here. K is 1.25. So y will equal 1.25, then times x. X represents any number of items that we take. So x, right there. And so this is the equation that models the dollar tree function. And we can use this equation to find the cost for any number of items. For example, if we want to estimate the cost for 1,000 items, all we need to do is multiply $1.25 times 1,000. That will be $1,250. Okay. How can we see this scenario on a graph? Okay, we want to have multiple representations of this proportional relationship. So we have a table here, we have an equation here now. Now let's look at how this proportional relationship looks like on a graph. So this is how we represent that dollar tree table on a graph. On this graph, we can see that one item costs $1.25. Okay, now why do all proportional relationships pass through the origin? This is one simple trick to identify the graph of any proportional relationship. The line must pass through the origin or must touch the origin. Okay? If I don't buy any item, if I go in there, that dollar tree, and I buy 0 items, guess what I'm going to pay? $0. So the origin, which is the point 00, tells you that in a proportional relationship, if you have 0, then the multiplier multiplied by 0, the constant of proportionality multiplied by 0 gives you 0. So all proportional relationships must touch the origin. So that graph there is proportional because we see it touching the origin or going through the origin. And we can see from this graph that one item costs $1.25. This is our constant of proportionality right there. So our constant of proportionality is $1.25. And if we were looking at this graph and we do not know the equation that has been used to plot this graph, the equation will be y equals k x, and this k represents the unit price. So the equation will be y. So in this video we have covered 3 things. We have been able to identify proportional relationships by using the constant of proportionality. We have been able to write an equation to model a proportional relationship, and we have been able to graph a proportional relationship and be able to write the equation of a proportional relationship if we're looking at a graph. Thank you. Again, I love the dollar tree.